Hello and welcome back. Today we've got an interesting tutorial about decoder layers. Now here's our decoder-only architecture, and what we're talking about today applies both in inference and in training. It's just the architecture of large language models, so it's the same in both cases. Now we're going to be talking about this little nx that has been on our diagram all along, and we haven't paid attention to it. Now, we're going to look at the example that we've discussed before. Apples are a type of delicious blank, and we're going to give this to the large language model, and we want it to predict the next word. So we're going to be looking at this in the context of inference. That's what we're doing here. But again, this applies both to inference and training. So we're going to input this into the transformer, and as we've discussed multiple times, these words will go through the architecture in parallel. The only time where they get to reference each other, with the caveat of masking, of course, the triangular masking, is in the multi-head attention component, where we're building context rich vector representations for each of these words. But ultimately, each word will have a vector that's been constructed, and all of this is happening in parallel to each other, and at no point do they all get mixed into just one answer or something like that. It's just constantly in parallel. These vectors are going through the transformer, and but that's not all. But that's not all. When the vectors get to the end of to the end of the decoder, just before the softmax and linear transformation, let's say up to over here, what will happen next is, instead of the softmax and linear transformation, they will be put into another layer of the decoder, and then into another layer of the decoder, and then hundreds more times, potentially, can be dozens, can be hundreds more times, and then it'll go into another layer of the decoder, of a decoder. And then it will go through the linear and the softmax. And this is what architecturally it looks like. So these vectors will go here, then they keep going, and so on. And what this allows is for the vectors to create, or for the model to create even more complex representations of the words, and learn non-linear relationships in language, and basically enhances the model. For example, in the original transformer paper, they had 6 layers. In the GPT-2 model, they had 12 layers. In the GPT-3 model, they already had 96 layers of decoders, and so on. So this kind of explains how the transformer can, or how the large language models can be so good at predicting words with such a simple architecture. Well, that's because there's multiple dozens and hundreds of layers stacked on top of each other that enhances the complexity of this architecture, or enhances the learning capabilities of this model. And just to quickly sum everything up, we're talking about this NX. So there we've got the input sentence. It goes into the decoder. All the tokens in the input sentence are passed through the transformer in parallel, not one by one, as we discussed. Then that goes into another decoder, and so on. There's NX layers. It can be 6 in the original paper. It can be 96. It can be over 100. It's up to the architecture design. The decoder layers are independent of each other with their own weights and with their own sets of weights and parameters. Very important. The weights that are being learned are different in each decoder. The vectors go in parallel like that. In the output, we get these vector context-aware vector representations, which are then with the softmax, with the layer, with the linear transformation, the softmax are converted into outputs, which are probability distributions. And this is these are context-aware representation. Yes, we've discussed that. This full output, very important, this full output is produced in parallel, not one by one. And if we would like to see layers in action, we can go to this tensor to tensor Colab, which is maintained by Google, and we scroll down to the bottom, and then here just select input to input, and you'll be able to change the layers here. So let's say you pick, these are the attention heads, right? So this is what in layer 0, the very initial layer, this is what the word, let's say it, is attending to. So let's look at that, right? And now if we change that to layer 5, and look at what it is attending to, you can see it's changing, and you might say that it's becoming more robust or more fleshed out what the word it needs to be attending to. So you can play around with this and select the different layers and see what's happening there. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.